Solve quadratics by completing the square. So what it says here, it says not all quadratic equations written in the form of ax squared plus bx plus c equals 0 are factorable. And that's because their solutions are irrational. In this case, we must use a different method. The third method of solving to factor it. So don't write this, but you might try to set it up like this and try to factor. And you're thinking, okay, what multiplies to -2 and adds to +6? But the truth is nothing. There is no couple of numbers that is going to multiply to -2 and add to 6. So you'd be staring at this problem forever because this problem isn't factorable. You can't use the factoring method. And the reason being is because the answers to this equation are these crazy decimal irrational answers. So you won't be able to factor this. So we have to use a different method, and it's called completing the square. So this completing the square method is pretty crazy. Try as hard as you can to follow along with it. But there's kind of a lot of steps, and it's very procedural. So it's kind of steps you almost pretty much have to memorize. Now they're logical, but you do kind of have to memorize the steps in which we do here. So when you're completing the square, contrary to the factoring, you don't want it equal to 0. So my first step, my first procedural step is I'm going to do +2. So now I have x squared plus 6x equals 2. And then this is where we get into this idea of completing the square. So what we're going to do is we're going to take, and this is going to seem very strange, we're going to take that b term. The b term, when I say the b term, I'm referring to this bx part. So I'm going to take that b number. In this case, it's 6. So I'm going to take that b number. In this case, it's 6. And again, this is going to be weird. I'm going to divide it by 2. Or in other words, take half of it. I'm going to divide it by 2 and then square it. And then I'll tell you what we do with it. But we're going to divide it by 2 and then square it. I'm going to do it off to the side. So I'm going to take 6, divide it by 2, and then I'm going to square it. And let's just do that in our heads. So 6 divided by 2 is 3. 3 squared, or 3 to the second power, is 9. And now what we're going to do with that 9 is we're going to add it to the x squared plus 6x to complete the square. So I'll show you what that means. So I'm going to do this. Now this, we added time, we've completed the square. And I'll show you what I mean by that a little later. But since I did the +9 on the left side of the equation, just kind of poof, appeared out of nowhere. Remember, to maintain equality, I'm going to have to do that to the right side. So I'm going to put a little +9 here too. Okay, so I've said it a few times, but now that we've done that +9 there, we have completed the square. And what I mean by that is that x squared plus 6x plus 9 is now factorable. The original problem wasn't, but now that we have an x squared plus 6x plus 9, we can factor that. And it factors, not only just factors, it's a perfect square trinomial. So this factors into x plus 3 and another x plus 3. That's how that factors. Of course, 2 plus 9 is 11, so I'll write that there. And x plus 3 times x plus 3 is x plus 3 squared. That's why we call it like completing the squares, because this is equivalent to this. We've created a perfect square trinomial when we completed the square. And then this is, I'll drag the 11 back down. And now we're going to start solving for x. Okay, so all that, those first steps are kind of just like a setup. And now we're going to start solving for x. Okay, so we have x plus 3 squared. In order to get rid of that quantity squared, I'm going to take the square root. Of course, I have to do it over here. That's going to leave this as just x plus 3. That gets rid of the squared. And the square root of 11 is going to be an irrational number like I was talking about. It's going to be some nasty decimal. If I type it in, I get something crazy. And we're not going to write that decimal because it's not an exact answer. So I'm just going to leave it as the square root of 11. More specifically, I'm going to leave it as plus or minus square root of 11. Kind of like the a couple lessons ago. Remember, when we're solving equations, it's going to be the positive and negative solution. And then again, we're just solving for x. So we only have one more step, really. We're going to subtract the 3 from both sides. Now, this may seem weird in how we write it, but math notation usually, because we're not going to be able to combine the square root of 11 and the negative 3. Negative 3 is an integer. We're not going to be able to combine it with that root symbol. So I'm just going to put the negative 3 in front. Math notation usually keeps it in front. And that's how we're going to have our answer. I'm going to box that because I want to leave it in its exact form. Sure, I could do negative 3 and then add it to whatever the square root of 11 is, that crazy irrational number, and get a decimal approximation. And then I could do negative 3 minus whatever square root of 11 is and get that crazy decimal approximation. But I'm going to leave my answer in its most exact form, and that's it. Okay, that was crazy. Let me show you B. Do some more here. All right. Let me go a little faster maybe. Subtract 3. Now I have x squared minus 12x equals negative 3. Now it's time to complete the square. I'm going to take half of the 12 and square it. So I'll do that off to the side again. I'm going to do half of the 12 or negative 12. It doesn't really matter because we're squaring it anyways. And I'm going to square it. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So I'm going to add 36 to both sides. By doing that, it completes the square. So x squared minus 12x plus 36, that completes the square. So x squared minus 12x plus 36 turns into x minus 6 and another x minus 6. Now, I'm not going to write that whole step out. I'm going to skip that there. I'm just going to rewrite this part as x minus 6 squared because that's equivalent. And then the negative 3 plus 36 is 33. Now we're at the point, we've completed the square. Now we're at the point of just solving. So we're trying to get x by itself. Now that entire quantity is squared on the right, or on the left, I mean. So I'm going to take the square root. Of course, I have to do that on the other side as well. So now I just have x minus 6. The square root of 33 is irrational, doesn't simplify. So I'm just going to leave it as plus or minus root 33. Then I'm going to add 6 to both sides to solve for x. General math notation, keeps the 6 in front. So I'm going to put the 6 in front of the plus or minus root 33. And I'm not going to go any farther. Again, I could find the square root of 33, get a decimal, do 6 plus that, and do 6 minus that. But I'm just going to leave it at this. It's its most exact form. So I'm going to leave it like that. Show you some more. I might go a little faster on these. C is nice because we can just complete the square right away. I didn't have to move anything over. So I'm going to take half of 8 and square it. So I'm just going to do that on my head. So half of 8 is 4. 4 squared is 16. So to complete the square, I'm going to do plus 16. This will factor into x minus 4 squared. 34 plus 16 is 50. Now we're solving for x. Take the square root. That'll leave this, That'll leave this as an x minus 4. And I'm going to call this plus or minus square root 50. Or square root 50 is not a perfect square. It's irrational. If you type it in, you'll get a crazy decimal. Add 4 to both sides. Put the 4 in front. Now, Before I box this answer, I'm actually going to take this a step further. Because the square root of 50, although it's not an integer, it doesn't simplify down to a whole number, it can be simplified, that radical. So we got to think back to an earlier unit. If we're going to simplify the square root of 50, I'll do that in green over here. I can break this up into two separate square roots where one of them is a perfect square. And I'm not going to get into specifics and talk you through the whole thing, but I'm going to pick 25 times 2 is 50 because the square root of 25 is 5. So I'm going to change this into 5 root 2. So I'm going to write my answer actually as x equals 4 plus or minus 5 root 2. So now it's a bit more simplified. Okay. I'll do D, but I'm going to go fast. Add 8 to both sides. Now I'm going to complete the square. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. The x squared plus 4x plus 4 simplifies, or factors, should I say, into an x plus 2 squared. 8 plus 4 is 12. Now we take the square root. So I'm just going to have an x plus 2 and then plus or minus square root of 12. So I took the square root. Maybe I'll show the symbol. Now I'm going to subtract the 2. Let's solve for x. Again, math notation, we usually put the negative 2 in front. Now I could box this as my final answer, but I can simplify that root a little bit. Root 12 doesn't simplify fully to an integer or a whole number, should I say. But you can simplify that radical. I'm going to do that in green up here in the top right. Square root of 12. 4 and 3. 4 times 3 is 12, and the square root of 4 is 2. So I can change that to a 2 root 3. So that's what I'm going to do. Negative 2 plus or minus 2 root 3. All right. Some more. These ones are a little different. At least the end is. Subtract 21 from both sides. I have x squared minus 10x equals negative 21 now. I'm going to complete the square. Take half of negative 10, square it. Half of negative 10 is negative 5. Negative 5 squared is 25. So I'm going to add 25 to both sides. The x squared minus 10x plus 25 factors into x minus 5 squared. Negative 21 plus 25 is 4. Then we take the square root to solve for x. So this is x minus 5. Now here's where it's different. Unlike all the other problems that we've done thus far, the square root of 4 does simplify fully. The square root of 4 is 2, right? More specifically, plus or minus 2 when we're solving. So it's not a radical anymore. It's just a whole number of 2, plus or minus 2. It's an integer. So this is actually going to allow us to take this a little bit farther here in a second. So solving for x, I'm going to do plus 5. Put the 5 in front. So I have 5 plus or minus 2. So we can get our final answers here, final whole number, fully simplified answers. Because x is 5 plus or minus 2. And 5 plus 2 is 7. And 5 minus 2 is 3. So our answers are 7 and 3. So if you didn't understand that talking, let me write it out. X equals 5 plus or minus 2. So x could equal 5 plus 2, which is 7. Or it could equal 5 minus 2, which is 3. So we actually, on this one, are able to go and get out full answers by completing the square. What this tells us in hindsight is that it was factorable, so we could have factored it. Now, don't write this, but like this original equation, we could have just factored into x minus 7, x minus 3, and then gotten positive 7 and positive 3 way quicker. But this just shows you that you can also use completing the square even if it is factorable. So like even on f, don't write this, but you could factor this into x plus 4, x minus 2, and get the answers of -4 and +2. That would be the quick way to do it, right? But let's just practice the completing the square again. Because let's say you're really bad at factoring. You just use completing the square. Add the 8. Take half of 2. So now it's time to complete the square. Take half of 2 and square it. Half of 2 is 1. 1 squared is 1. This will factor into x plus 1 squared. 8 plus 1 is 9. Take the square root of both sides. Got x plus 1 equals, now again, square root of 9. Simplifies down to 3. Plus or minus 3. So -1 plus or minus 3. So -1 plus 3 is 2. -1 minus 3 is -4. So those are my answers, 2 and -4. But I'll write it out. -1 plus 3 is 2. -1 minus 3 is -4. And that's completing the square. So those are kind of all the cases. Some where it's not going to simplify at all with the square root. And then some where it's not going to fully simplify with the square root down to an integer, but it will can simplify the square root a little bit up. And then, sometimes we'll get out whole number answers or integer answers. So I'll let you do the rest of those. Let me do 1 or 2 of these. So what he says here, these 4 problems are a tougher challenge because the coefficient b of the x term, the middle term, is an odd number. I don't know if you noticed, but all the ones up here were all even numbers for b, like 6 and 10 for there, and 4 and 12 for there, and 8 and 14, and 10 and 2. Like those are all even numbers. So it's easy to divide those by 2 and square it. These ones are going to make it more difficult because this number is odd. So like you see how it's got a 3. So dividing that by 2 decimals gets all nasty. So let me just show you, just in case you have any ones like these and you want to use completing the square. Usually I try to avoid the completing the square method when that middle term is odd, but I'm going to go ahead and show you one of these, okay? So the 10's already over there. We're good. So we got to take half of the middle term and square it. So I'm going to write it out this time, 3 over 2, and I'm going to square it. Well, 3 divided by 2 doesn't simplify, right? It's 1.5, and we don't want to go to decimals. So I'm just going to square it as it is. 3 squared is 9. 2 squared is 4. So I'm going to add that to both sides. Now I'm going to complete the square. So x squared minus 3x plus 9 over 4. If I'm trying to factor that, remember as we're always factoring this, when we complete the square here, that number in the parentheses is always half of that b term. I'm not sure if you've been noticing that, but let me scroll up to some other examples. Like here. This 5, half of the 10. This 1, half of the 2. This -4, half of the -8. This 2, half of the 4. So it's always half in there. So that's kind of a good indicator. So I'm going to put -3/2 in there because that's half of -3. 10 plus 9/4. I'm just going to use my calculator for that. It's 12 1/4. I'm going to keep it as a improper fraction. That's 49/4. Okay, so then you take the square root. It's going to be, let me show it. I meant to use red, but whatever. Dang it. X minus 3/2 equals plus or minus square root of 49 is 7. Square root of 4 is 2. Add the 3/2. So this one's nice because it's that when I did the square root of 49, it simplified fully, and the square root of 4 simplified fully. So that's going to be 3/2 plus or minus 7/2. So my two answers would be 3/2 plus 7/2, which is 10/2, which is 5. My other answer would be 3/2 minus 7/2, which would be -4/2, which would be -2. So yeah, crazy, right? With the fractions, gets really, really messy. Why don't I do n as well? X squared minus 5x equals -3. Half of -5, square it. That would be 25/4. Add it to both sides. Sorry if I'm going really fast. I just want to give you one more example just in case you need it. Whoops. But like as I said, I try to avoid this method. The next lesson, you're going to have a method that's easier for ones like these, in my opinion. Not to scare you away from completing the square, but it can be pretty crazy. So half of -5 would be -5/2. -3 plus 25/4. That would be -12. I'm trying to do it in my head. 13/4, I think. Hope so. Take the square root. I get x minus 5/2 equals. So yeah, this one's different because the square root of 13 doesn't simplify. So I'm going to have plus or minus root 13/2 because the square root of 4 does simplify. And then add the 5/2 over. I'm not going to show it, but we'll have 5/2 plus or minus root 13/2. Okay. Yeah, crazy.